right, Kira and Maya, this is 9-4 notes. There's only one example here, but the icky part is that we have two new tables to look, well, a couple new tables. You have 4 pages of tables to look at, okay? 1, 2, 3, 4. So I'll explain to you how we're gonna use those tables here in just a second. So 9-4. Let's go through and let's write down some stuff. We are testing standard deviations, okay? So we're looking at 2 standard deviations. What symbol do we use for standard deviation?
Sigma.
Sigma, right? This is our claim variable, okay? What's the variable that we use for the sample? S, right? Okay, S is the sample, so that's the sample data that they give us, but we're using that to represent our claim. Got it? Okay, good. All right, here we go. Let's go down to our example and let's write some stuff down. Researchers from the University of British Columbia. Kelsey, listen.
Columbia!
Researchers from the University of British Columbia conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. You got to be quiet. Subjects with a red background, underline things. Red background, we're asked to think of creative uses for a brick. They probably just made a wall, right? Other subjects with a blue background were given the same task. You have to be a little bit more creative if they give you the color blue to make a brick, right? Responses were scored by a panel of judges and results from scores of creativity were given below. Here is the alpha value that they want us to use. Okay, test the claim that the creative task scores have the same variation. Same variation. We're not going to do variation. We're going to do standard deviation instead. Okay, we're not going to do variation. We're going to do standard deviation instead. So here we go. Standard deviation. Standard deviation. Okay? Our null hypothesis is that they're equal to each other. So mu1 equals sigma 1 equals sigma 2. Right? Okay? Now, we don't do like the mu d equals 0. That was only in matched pairs. That was in the last one that we did. So we are back to doing sigma 1 equals sigma 2, right? What's our alternative? Not equal to. It doesn't say greater than. You guys got to be quiet. Not equal to. Okay, so when we have this going on, how many tails? 2 tails. Let's shade them. Boop, boop, boop. Boop, boop, boop. There's my 2 shaded tails. Okay. All right. What percentage is in each one?
5.
Fish value is 5%.
2.5.
2.5%. Because we have to split it. 2.5%, 2.5%. Okay. Got it? That would be like 95% in the middle, right? Okay. All right. Here is our information. You guys have to be quiet. You're making this take longer. If you be quiet, this won't take as long. Red background, blue background, these are the scores that they gave. N, they had 35 people. 36 people that had a blue background. Those are just the number of people in each class or whatever, okay? The average score, hey, is it really?
Yes.
Nice, okay.
I'm doing it on that.
Sure, go for it, okay? X bar, so the average score for the people with a red background was a 3.39. They didn't score as high because they weren't having to be as creative. So they probably just like did something really boring and got really low scores. 3.97 was the score for the people who had a blue background. Probably like gave them bonus points for creativity because they had a blue background with a brick. Standard deviation is 0.97 versus 0.63. We are trying to test to see if those standard deviations are the same. Now, what does standard deviation do for me? Like, what does it mean? How much it deviates. So, like, the scores were all over the place, right? Like, some people scored really high, some people scored really low. Which one had bigger range of scores? The red background people, they had a higher standard deviation. So, some of them scored, like, 1. Some of them scored a 5. They scored all over the place. Versus the blue background people, they had more consistent scores, maybe in like the 3 to 4 range, right? Okay, those were my blue background people. So we're trying to test to see if these standard deviations are the same or if the red background does in fact give us more deviation, like more wider range of scores, all right? The test value, the formula for that is just this guy right here. It's really easy. Our variable that they call it is F for some reason. You know how we've had like Z and we've had T and we've had chi-squared. This is F, which means we're using the F table. So we do S1 squared over S2 squared. Now, here's the deal. This is the part, and I want you to put a little star here. S1 does not mean the first one, and S2 does not necessarily mean the second two. It is the bigger one over the smaller one. So whatever value when you square it is bigger goes on top. Always. That's going to be your 1s and 2s. Got it? That's the way that this works. So star, it has to be big over small. Not necessarily in order. 2.37. NECESSARILY. Not necessarily in the order that they give you above. Okay, so make a real big note of that. Not necessarily the order from above. You're going to take S1 squared, S2 squared, whichever one's bigger goes on top. Okay,
so
here we go.
On the positive side?
Yes, so we're always looking for the positive. Oh, that's something I'm going to add to this, okay? So our two S's are 0.97 and 0.63. If you take 0.97 and you square it, what do you get?
I have the answer.
Okay, what's 0.97 squared? Somebody give it to me. 0.9409. Perfect. What's 0.63 squared?
Oh, like
0.3969. Perfect.
Oh my God.
Okay, so in this case, it does go kind of in order that this is going to be my top one and this is going to be my bottom one. So red is going to be represented by 1s, blue is the 2s, right? It might not be that way when you do go and actually do it, right? It might be the top one's the 2 and the bottom one's the 1, right? Okay, so when we do 0.9409 divided by 0.3969. 2.37 is what you get? Yeah? Okay. All right, so that's my number, 2.37. Got it? Okay. Now, the fact that, Marcus just said this, the fact that we are always doing the bigger number divided by the smaller number means that we will never be looking at this tail, correct? We will always be looking at the positive end. So we don't have to label the other one. We're always going to be on the right side. Does that make sense?
Yep.
Big divided by small will always end up with a number on the right side, okay? All right, now here's how we find the number on the right side. 2.32 is the value of F. We need to find the number on the table to compare that to. Got it? Or 2.3, was it 2.32?
No, it's 2.37. You just.
I just said 2.32. I'm sorry. 2.37. There you go. Okay. All right. Let's figure out our number from the table, and then we just compare, and we're done. Okay. So from these tables, you've got a couple different tables. Let me show you how this works. Okay. Numerator degrees of freedom.
34.
Numerator degrees of freedom. Okay. Which one was the numerator one? The red or the blue? Numerator.
Red.
I think red was on top, wasn't it?
Red was on top.
Red was on top. Okay. N for the red was 35, right? So our degrees of freedom there is going to be 34. Now we have to decide which table we're going to use. So is there 2.5% in the right tail?
Yeah.
Yes, so we're going to be on the first page. If you go to the second page, just to see how this works, this is 2.5% on the right tail, but this is more degrees of freedom, I think. Oh, wait. It goes this way, okay? Numerator degrees of freedom, denominator degrees of freedom. What's my degrees of freedom for the denominator? 35. So we're looking at 35 and we're looking at 34. Do you see that? Okay? So this table right here is just continued over here because here they start at 10. Do you see how that works? Okay? Okay? The second sheet of paper has 5% in the right tail, right? And same thing with the fourth page, has 5% in the right tail. So this table, the third and the fourth page table, will be exactly the same. It's just continued on. It's just a bigger table on 2 sheets of paper. Make sense? Yeah. Okay. So we're going to be looking at 34 degrees of freedom in the numerator, 35 degrees of freedom in the denominator. So 34 and 35. If I look for, so I'm going to be on the second page, right? 34, 35. 34 here, I'm looking between 30 and 40. Which one do you go with?
30.
Never assume more accuracy than you have. So we're going with 30 here. Okay. We want 35 degrees of freedom here.
It's 30.
And they don't have 35. So we go 30, 40. Which one are you going to use?
30.
The 30. So 30.
2.07.
30 and 30.
It's always been.
If we go over 2.079, yeah?
Yep.
2.0739, okay? That's the number that I'm going to use. Do you see how we picked that number off the table? All right, let me go back to my notes. So this guy is 2.0739. That's the number right here. So where does my number live?
Right on the outside.
Right on the outside, okay? He is over here, right? So what does that mean? Which one are you going to circle? Which one are you going to cross off?
It's reject H naught, claim false.
They're not equal to each other because he is on the right side, okay? So, yep, reject H naught. Which one was our claim, though?
The equal to.
To test the claim that they have the same variation. So we are claiming that they are the same, which means our claim is false. Okay?
Effects of alcohol.
All right, so what does this mean?
I'm too busy.
It
In
means-
actual words,
Eyes on the side of my head.
It means that
the
the red
deviation,
Where are you?
write this down, the deviation of scores
Oh, no, I'm not even touching.
for red vary more or less.
Wait, what?
The deviation of scores for the red background vary more or
Why
less.
did we reject it?
Because 2.37 is on the outside of 2.0739.
What?
What?
2.37. Oh.
Oh.
You're right.
Oh.
You're
Hey.
right. Sorry.
All right, so we're rejecting. We're saying they're not equal to each other. So the deviation of scores for red, I'll just say for red and blue do not vary the same. Okay? Which means they don't have the same variation. We have one group that is having scores all over the place from 1 to 5 or whatever, right? We have another group that the scores are a little bit closer together. They do not have the same variation. Make sense? Good? Yes? Okay, so that's all I have for you. You guys already have that for number 1 on your homework assignment. If you wrote the notes down on the actual notes page and you don't want to copy it over, you can just cross this one off, okay? If you wrote it on the homework assignment, good for you. Okay? Good? You don't have to rewrite it, okay? So, 2, 3, and 4, and 5, there you go. Number 4 is the only one, I think, that you have to calculate your data from, right? Got it? Okay. All right, yes. That is all that I have. Yes.
Island CG.
Goodbye, people in the video.